This is my Module 3 project. So, let's review the circle definitions. So remember that when a straight line goes through a circle and that it touches at 2 points on the circumference, that it is called a secant. The diameter of the circle is a line segment that runs from end to end, and it's a straight line. The chord is a line segment that has its 2 endpoints on the circumference of the circle. And a tangent line is a line that only has a single point shared with the circle. The point of tangency is where the tangent line touches the circle, and then the radius is half of the diameter. So, just another little quick review. The equation of a circle. So the equation of a circle, it's what we use to graph the circle. So in order to graph it, we need to know the center and radius, which is found in the equation of the circle. So the standard form is x minus h squared plus y minus k squared, that equals r squared. So the center of the circle on a graph is HK, which is going to be found in the standard form, and then R is the radius. And so here's an example. X minus 1 squared plus y minus 3 squared is 4 squared. So the center and radius. So what's the center and radius? The center is, as we see here, is 1, because that's the x, and then 3 is the y, and then the radius is 4. And then this is the expanded form of a circle. It's when we just have expanded the equation of a circle, and it's not in standard form anymore. And so it's ax squared plus by squared plus cx plus dy equals 0. So here's a little example. X squared plus y squared plus 4x minus 4y minus 17 equals 0. And so what we have to do is we have to combine our like terms, as we see here with the x squared plus the 4x. But then we have to find this perfect square and expand on that. And in this case, it's a positive 4. Same as over here with the y squared minus 4y. But this perfect square is a positive 4. And then we have our minus 17 equals 0. But since we added on 2 4s when we derive the square, we have to do it also to the other side, because it is what is needed in order to keep the equation equal. And so then when we simplify, we end up with x plus 2 squared plus y minus 2 squared equals 25. And so to see if a point lies on the circle, we need to plug the values given into the equation that we get. So as an example, so we need to see if point 73 lies on a circle with its center located at 3, 1 and has a radius of 5. So we derive our standard form equation of the circle, which would be x minus 3 squared plus y minus 1 squared equals 5 squared. And so then we plug in our values and we simplified the radius. And so we have 7 minus 3 squared plus 4 minus 1 squared. So when we simplify, get 16 plus 9 equals 25. And once we add those up, we get 25. And so 25 does equal 25. And so that means yes, the point does lie on the circle. So today we're talking about inscribed and circumscribed angles. So an inscribed angle is an angle formed by two chords in a circle that have a common endpoint, like this picture here. And so they form the endpoint inside of the circle. Usually it'll be like this. And so the inscribed angle theorem is the measure of the inscribed angle is half of the measure of the intercepted arc. So meaning like if this arc right here is 60 degrees, then this angle created by the two chords, the inscribed angle, is 30 degrees. And so any inscribed angle from the same 2 points, they are congruent to each other. So like if I have this inscribed angle right here, and then if I have another inscribed angle that's created from the same 2 points, that angle created there is also going to be 30 degrees. If it creates a semicircle, if the two chords are just creating a semicircle, then you will always have a right angle. And so this is circumscribed angles. So a circumscribed angle is an angle formed by two tangent lines that have a common endpoint. And remember, tangent lines only have one single point of connection with the circle, and they form one common endpoint. And they form the endpoint outside of the circle. And so this is a property of circumscribed angles. So for circumscribed angles, the measure of the angle and the arc that it circumscribes must add up to 180 degrees. And so it'd be the angle that the two tangent lines create plus the arc that is inside the two tangent lines. That has to add up to 180 degrees. And that's all for today.